Good evening, and welcome to Calm Science for Sleep, where the universe is told softly, one quiet fact at a time, at the pace of a slow breath. Maybe today asked a great deal of you, or maybe you're simply the kind of person who would rather drift off, wondering about distant stars than counting sheep. Either way, tonight belongs to you. There is nothing left to do now but rest, so let your shoulders grow heavy. Let your breathing slow. Let your body grow light, as if gravity itself has loosened its hold and you have begun to float, quietly, out past the ceiling, past the rooftops, past the pale glow of the city, into the dark. Because tonight, we are drifting through our home, the Milky Way, a vast, slow spiral of a few 100 billion stars, turning through space for more than 13 billion years. And beneath its calm and shining surface lie stranger things, stolen stars, invisible rivers of matter, a sleeping giant at its heart, and the faint, unfinished story of a galaxy that is still being built. I'll share 100 quiet facts about it tonight, and somewhere among them, one may gently surprise you, though there is no need to stay awake to find it. If sleep comes on the 10th fact, or the 40th, simply let it. The galaxy will keep turning without you, and it will still be here in the morning. If these calm journeys help you rest, a soft tap on like or subscribe helps another sleepless soul find their way here too. But that can wait until morning as well. For now, let your eyes close, and let's begin. The Milky Way is on a collision course with another galaxy. Right now, the great spiral of Andromeda is falling toward us through the dark, closing the gap at about 110 kilometers every second. In roughly 4.5 billion years, the two galaxies will meet, pass through one another, and slowly merge into a single, larger one. Yet almost nothing will actually crash. Stars are spaced so far apart that they will simply glide past each other, like two swarms of fireflies drifting through the same field. Our own sun will most likely survive, flung gently into a wide new orbit within the merged galaxy. And for millions of years, the night skies of any world still watching will fill with the slow, silent turning of two great spirals becoming one. What we call a collision is really a slow, silent embrace, a merging so gentle it will take hundreds of millions of years to finish. Our sun is racing through the galaxy faster than any bullet. It may feel as though you are lying perfectly still, but you are moving. The sun, and everything orbiting it, including you, is carried around the center of the Milky Way at about 230 kilometers per second. That is more than 800,000 kilometers every hour, faster than any bullet ever fired. And still, the galaxy is so enormous that a single lap takes around 230 million years, a span so vast that astronomers call it a galactic year. The last time the sun stood where it stands tonight, dinosaurs had not yet walked the Earth. In its entire long life, the sun will circle the galaxy only about 20 times. You are traveling at unimaginable speed and never feel a thing, held so smoothly by gravity that the motion feels like rest. Almost everything you can see in the night sky lives inside one galaxy. When you look up at the scattered stars, nearly every point of light belongs to the Milky Way, our own small neighborhood within it. Out of a few 100 billion stars, The unaided eye can see only a few thousand at a time, and only those close enough to shine as separate points. The rest blur together into that soft, milky band the ancients named a river of light, a glow that is, in truth, the blended shimmer of billions of distant suns too far away to tell apart. Only a mere handful of things visible without a telescope, like the faint smudge of Andromeda, lie beyond our galaxy at all. Everything else you have ever wished upon, every constellation ever drawn, is a handful of nearby lanterns in a single, quiet corner of home. The Milky Way is far larger than it looks. Our galaxy stretches roughly 100,000 light-years across. Light itself, the fastest thing that exists, able to circle the whole Earth 7 times in a single second, would still need 100,000 years just to cross from one edge of the Milky Way to the other. And that is only the bright, star-filled disk. A faint halo of old stars and dark matter reaches far beyond it, so the true edge is blurry and uncertain, perhaps stretching outward for hundreds of thousands of light-years more. Within that span drift a few 100 billion stars, each one a sun in its own right. We live inside something so wide that our fastest messenger would grow old many times over before reaching the far shore. We have never seen our own galaxy from the outside. Every breathtaking image of the Milky Way as a perfect spiral is, in truth, an artist's careful guess. We live deep within its disk, and no spacecraft could ever travel far enough to turn around and photograph it whole. It would take longer than the age of the universe. Instead, astronomers map our galaxy the way you might map a forest, while standing among its trees, measuring the distance and motion of star after star. One patient spacecraft, named Gaia, has now charted the precise positions of nearly 2 billion of them, slowly assembling a 3-dimensional portrait of our home. It is careful work like this that revealed the Milky Way is not a simple spiral at all, but a barred spiral, with a long bar of stars laid across its center, a shape we are still, quietly, learning to see. The Milky Way is older than almost everything in it. Some of the stars in our galaxy's outer halo are nearly 13 billion years old, formed not long after the universe itself began. They are pale, slow-burning, and remarkably poor in heavy elements, because they were born before generations of dying stars had seeded space with iron and carbon and gold. One such ancient sun, drifting not far from us, is nicknamed Methuselah. For a time, astronomers measured it to be almost as old as the cosmos itself. These stars are living fossils, carrying in their faint light the simple chemistry of the earliest universe. When you gaze toward them, you are looking at some of the oldest light still shining anywhere, survivors from the first chapters of time, still quietly holding their place in the dark. Not every star in the Milky Way was born here. Our galaxy is not a single, tidy creation. It grew by devouring others. Over billions of years, the Milky Way has pulled in and torn apart dozens of smaller galaxies, weaving their stars into our own. One of the largest, a galaxy astronomers call Gaia Enceladus, crashed into us some 10 billion years ago, and its captured stars still sweep through our halo today. Even now, a small galaxy in the direction of Sagittarius is being slowly stretched and swallowed on the far side of the Milky Way. Many of the stars in the halo above and below us are refugees, born elsewhere, in galaxies that no longer exist. We live in a spiral, stitched together from the ruins of 1,000 smaller worlds, a home built quietly from everything it once consumed. Some stars in our galaxy are moving the wrong way. Most stars orbit the galactic center in the same broad direction, like a great slow current, but a few travel against it, circling backward through the disk. These are almost always outsiders, stars captured long ago from galaxies the Milky Way absorbed, still keeping the motion of a home that no longer exists. Astronomers find them by tracing streams of stars that all move together against the flow, and by reading the chemistry hidden in their light, which often differs from that of stars born here. Their reversed motion is a quiet signature of a foreign origin, a memory carried faithfully for billions of years. Even now, they drift among us, still turning the way their vanished galaxy once taught them to turn. From the stars themselves, we drift now toward the shape they trace, the great spiral arms, and the questions still hidden within them. We still don't know exactly how many arms the Milky Way has. It seems like it should be simple to count, yet because we live inside the disk, dust clouds obscure the far side, and distant stars blur into one another. For decades, astronomers pictured 4 grand spiral arms, with names like Perseus, Sagittarius, and Scutum Centaurus. Newer surveys, tracing the light of young stars and glowing gas, suggest perhaps 2 major arms, with fainter branches spurring off between them, one of which, the small Orion spur, is where our own sun quietly lives. To map them at all, astronomers must measure the exact distances to bright beacons of gas scattered across the galaxy. The honest answer is that we are still counting the arms of our own home, sketching the outline of a room we have never been able to leave. The spiral arms are not solid, they are waves. It's tempting to imagine the arms as fixed pinwheels of stars sweeping through space, but stars do not stay in them. The arms are more like traffic jams of light, regions where stars and gas slow, pile up briefly, glow, and then move on. A star drifts into an arm, lingers, and leaves again over millions of years, just as cars crawl through a jam and then speed away down an open road. It is here, where the gas is squeezed together, that new stars ignite, which is why the arms shine so brightly, lit by young, blue suns. The beautiful shape you picture is real, but it is a pattern, not a place, a standing wave written across a sea of moving stars. The Milky Way is not a flat, perfect disk, it's warped. From afar, our galaxy might look like a smooth, level plate. Up close, its outer edges bend. One side of the disk curves gently upward, the other downward, like the brim of a hat that has lost its shape. Astronomers mapped this by tracing pulsing stars called Cepheids across the galaxy and found the whole disk twisted into a vast, gentle S. The warp is thought to come from the gravity of passing dwarf galaxies, chiefly the Magellanic Clouds, and unseen dark matter tugging at the rim, and it slowly wobbles as the galaxy turns. Our home is not a flawless design, but a living thing, slightly bent, slightly rippling, shaped by every companion that has ever drifted near. The galaxy's disk has 2 layers, one hidden inside the other. The Milky Way's disk looks like a single sheet, but it is really 2, nested together. There is a thin disk where the sun and most young, bright stars live, still quietly forming new suns even today. And wrapped around it lies a thick disk, older, puffier, and more diffuse, home to stars that formed more than 10 billion years ago, under wilder conditions. The stars of the thick disk carry a different chemistry, richer in certain elements, a fingerprint of the galaxy's turbulent youth, which lets astronomers read our home's history age by age. Like sediment settled on the floor of a cosmic ocean, the layers record that history, the calmer years laid gently over the turbulent ones beneath. Trails of stolen stars stretch across the sky like faded ribbons. When the Milky Way pulls apart a smaller galaxy, the victim does not vanish all at once. Its stars are stretched into long, thin streams that wrap for tens of thousands of light years around us. Dozens of these stellar streams have now been mapped. The grandest, torn from the Sagittarius dwarf galaxy, loops almost entirely around the Milky Way, like a ribbon around a gift. Astronomers treasure these delicate trails, for a passing clump of invisible dark matter can leave a gap or a ripple in one, making the streams among our finest tools for sensing the unseen. They are the quietest kind of ruin, no fire, no sound, only a slow ribbon of light, still tracing the path of something that is no longer whole. Some stars are being flung out of the galaxy entirely. Every so often, a star wanders too near the violent heart of the Milky Way and is slingshot outward at a staggering speed, fast enough to escape the galaxy forever. Astronomers call these hypervelocity stars, and the first were found only in 2005, racing outward at more than 1,000 kilometers every second. Many are thought to be flung by a close brush with the giant black hole at the Galactic Center, which can seize a pair of stars, tear them apart, and hurl one away like a stone from a sling. They are leaving home for good, drifting out into the empty dark between galaxies, where they will wander alone for the rest of time. Somewhere out there tonight, a star is quietly crossing the border of everything it has ever known, and it will never return. The Milky Way is still growing, even now. Our galaxy is not finished. It is still drawing in gas from the space around it, still pulling on small companion galaxies, still forming one or two new suns every year from cold, collapsing clouds. Fresh hydrogen rains down onto the disk from the surrounding halo, and vast clouds of gas, like one called the Smith Cloud, can be seen falling inward even now, destined to kindle new stars when at last they arrive. The spiral you picture is a work in progress, 13 billion years old and still unfinished, still quietly building itself. As you lie here tonight, somewhere far out in the black, a new star is beginning to glow, and the galaxy is becoming a little more than it was yesterday. And at the center of all this turning motion, there is a stillness, a heart. So let us drift, slowly, inward, toward the quiet monster at the middle of it all. At the center of the Milky Way sleeps a giant black hole. Far in toward the middle of our galaxy, some 26,000 light-years away and hidden behind thick veils of dust, lies a black hole with a mass of about 4 million suns. Astronomers call it Sagittarius A star. It is the anchor around which the entire galaxy quietly turns, a point so dense that not even light can climb back out of it. Its mass was pinned down over decades of patiently watching stars swing around it, work honored with a Nobel Prize in 2020. And yet, despite its power, it makes no sound and gives off almost no light of its own. It simply waits at the heart of everything, patient and dark, holding 100 billion stars in its slow, invisible embrace as they drift around it through the ages. We have actually seen its shadow. For most of history, the black hole at our galaxy's heart was purely a thing of mathematics, believed in, but never seen. Then, in 2022, a network of radio telescopes spread across the whole Earth worked together as a single instrument the size of the planet and captured its silhouette, a dark circle ringed by a faint halo of glowing gas, 26,000 light-years away. The bright ring is starlight and gas bent into a circle by gravity, so intense it curves the path of light itself. It was the first time humanity had ever looked directly at the monster at the center of our home. A portrait of something that, by its very nature, can never truly be photographed, only outlined by the light falling helplessly around it. Our galaxy's black hole is unusually calm. Some galaxies have black holes that blaze with the fury of devoured stars, outshining every sun around them. Ours does not. Sagittarius A star is, by cosmic standards, remarkably quiet, feeding only lightly on the thin gas that drifts too near, shining at a tiny fraction of the power it could unleash. If it were a fire, it would be little more than glowing embers. Were it to blaze like the fierce hearts of some other galaxies, our night sky would burn with its glow and bathe the Earth in radiation. This gentle stillness is part of why life could arise here at all. We orbit a sleeping giant, not a raging one, and its long, quiet rest has helped keep our corner of the galaxy calm enough for worlds like ours to form and endure. Stars near the center whip around it at staggering speeds. Close to the galactic heart, a handful of stars trace tight orbits around the black hole. One of them, known as S2, loops around every 16 years, and at its closest approach, it races along at nearly 3% of the speed of light, thousands of kilometers every second. By watching these stars swing around something unseen, astronomers weighed the invisible giant and confirmed it was truly there. In 2018, they even watched S2's light stretch and redden as it whipped past the black hole, exactly as Einstein's theory of gravity had predicted a century before. They are like moths circling a lantern in the dark, tracing with their motion the shape of a thing the eye can never find. The heart of the galaxy is hidden from our eyes. If you look toward the constellation Sagittarius, you are gazing straight at the center of the Milky Way. Yet you cannot see it. Between us and the core lie thousands of light years of dust and gas, so thick that they dim its visible light by a factor of 1 trillion, swallowing it almost entirely. To peer through the veil, astronomers turn to infrared and radio waves, and telescopes like James Webb, which slip past the dust untouched to reveal the crowded core beyond. The busiest, brightest place in our galaxy is completely invisible to the naked eye, a grand and crowded city, hidden forever behind a curtain of interstellar fog. Two enormous bubbles rise above and below the galaxy, In 2010, a space telescope named Fermi discovered something vast and unexpected. Two colossal bubbles of high-energy gas, ballooning outward from the Galactic Center, each reaching some 25,000 light-years into space. Together, these Fermi bubbles stretch across more than half the width of the entire galaxy. A decade later, an even larger pair was found glowing in X-rays, wrapping the whole galaxy in unseen shells. They are likely the fossil of some ancient outburst, a time, millions of years ago, when our now quiet black hole was fierce and feeding. They stand like silent monuments to a violent past, glowing softly in gamma rays, a memory of fire written into the sky, above and below our home. The Galactic Center is one of the most crowded places in the universe. Out here, in our quiet suburb, the nearest star is more than 4 light-years away. But near the heart of the Milky Way, stars are packed millions of times more densely, tens of millions of them, swarming within just a few light-years in a glittering cluster around the black hole. There, stars sometimes pass so close that they disturb one another's orbits, and now and then even collide. If Earth orbited a star in that crowd, the night sky would blaze with thousands of brilliant points, some bright enough to cast shadows, a sky never fully dark. We live in a peaceful, spacious corner, far from that dazzling, restless throng at the center of it all. The center is not only crowded with stars, but ringed and fed by rivers of gas. Let us look a little closer at what surrounds the giant. A ring of cold gas encircles the black hole. Around Sagittarius A star, beginning only a few light-years out, lies a slowly turning ring of cold molecular gas and dust, sweeping around the darkness at roughly 100 kilometers every second. Astronomers call it the circumnuclear disk. It is the reservoir from which the black hole may one day feed, orbiting like a moat around a sleeping castle, with thin streamers of gas spiraling inward toward the giant. Within it, gravity and radiation wage a constant, silent struggle. It is a strange and delicate structure, so close to the most destructive object in the galaxy, yet turning on, patient and intact, holding its shape in the fierce glow of the crowded heart. Our galaxy's black hole would fit inside Mercury's orbit. For all its 4 million suns of mass, Sagittarius A star is surprisingly small. The dark sphere from which nothing escapes, its event horizon, is only about 17 times wider than the Sun, roughly 24 million kilometers across. If you placed it where our Sun now sits, the entire black hole would nestle comfortably inside the orbit of Mercury, the closest planet. All that immense weight, all that gravity, folded into a space smaller than the inner solar system. It is one of the strange truths of the cosmos. The heaviest things can also be among the most compact, hidden in a point of quiet dark. Radio waves first revealed the galaxy's hidden heart. We would never have found the black hole by looking. Its discovery began in the 1930s, when a young engineer named Carl Jansky, studying radiostatic for a telephone company, noticed a faint hiss that rose and fell with the stars, a signal coming from the direction of Sagittarius. It was the accidental birth of radio astronomy. Decades later, in 1974, astronomers traced that hiss to a compact, powerful radio source at the exact center of the galaxy, and named it Sagittarius A star. Invisible to the eye, the heart of the Milky Way had been quietly broadcasting all along. We heard our galaxy's center long before we ever saw it, a whisper in radio, waiting patiently to be understood. The black hole occasionally stirs in its sleep. Though calm, Sagittarius A star is not entirely still. Nearly every day, telescopes catch it flaring, brightening for hours in X-rays and infrared as a clump of gas is stretched, heated, and swallowed. In 2014, astronomers watched a whole cloud of gas swing past it and, to their surprise, survive. These flickers are brief, gentle by cosmic standards, and then the quiet returns. There are also hints that, only a few million years ago, it woke far more violently, sending light and energy roaring across the galaxy. It rests now, but not forever. Even a sleeping giant shifts and murmurs, and the heart of our galaxy dreams in slow, occasional flashes of light we are only beginning to understand. Everything in the galaxy is, in a sense, orbiting the center. The sun does not wander freely. It circles the galactic heart in a vast, patient loop, carrying the Earth and every planet with it. And it is not alone. A few 100 billion stars all move together in the same immense, unhurried dance, bound by the gravity of everything within. Even the great black hole is not truly the still point at the center. It too drifts a little, nudged by the galaxy turning around it. The center holds them all, the crowded core, the sweeping arms, the faint halo, the sun, and you. To lie here tonight is to be part of a single turning wheel, so wide and so slow that a single revolution outlasts the rise and fall of entire species. If our black hole vanished, the galaxy would barely notice. It is tempting to imagine the central black hole as the thing that holds the galaxy together, but its 4 million suns are only a tiny fraction of the Milky Way's total mass, which, counting all its unseen matter, runs to more than 1 trillion suns. The black hole is less than 1/1,000,000th of the whole. If it disappeared tonight, the stars nearest the center would drift free, but the galaxy as a whole would keep turning almost unchanged, held together instead by the vast, unseen weight spread all throughout it. The true anchor of our home is not the black hole at its heart, but something far larger and stranger, woven invisibly through all of space around us. The center of the galaxy is a doorway we may never cross. Everything we know of the galactic heart, we have learned from a safe and enormous distance, 26,000 light-years of dust and time between us and it. The light and radio waves we study left the core 26,000 years ago, when the last ice age still gripped the Earth. We see it only as it was, never as it is. No probe will ever travel there. No eye will ever see it directly. It remains a place we can measure, but never visit, imagine, but never touch. And perhaps there is a quiet comfort in that. The most powerful thing in our galaxy sits far away, wrapped in shadow, turning slowly on without us, while we rest safely out here in the calm and spacious dark of a distant spiral arm. The heart of the galaxy is where stars end their long lives, but out here, along the quiet arms, is where they begin. Let us drift now to the great glowing clouds where stars are born. Stars are born inside vast, cold clouds of gas and dust. Scattered throughout the Milky Way are enormous clouds, light years wide, of gas so cold and dark that within them, gravity can slowly gather matter into new stars. We call them stellar nurseries. The most famous, the Orion Nebula, hangs in the sword of the Hunter's constellation, some 1,300 light-years away, a faint smudge to the eye, but a cradle where thousands of new suns are quietly forming right now. Within it, telescopes have found young stars still wrapped in swirling disks of gas that may one day become planets. Every star you have ever seen began this way, as a slow collapse in the cold and the dark, gathering warmth over millions of years until at last it kindled and began to shine. Our galaxy quietly makes a few new stars every year. For all its size and age, the Milky Way is a gentle, unhurried creator. Each year, it gathers enough cold gas to form only a handful of new stars, roughly 1 to 3 times the mass of our Sun. Some distant galaxies blaze with hundreds of new stars a year, but ours has always been calm, and its birth rate has slowed gently over the ages as its gas is used up. So even tonight, as you drift toward sleep, somewhere in a distant cloud, a new star is beginning to glow for the very first time. A small, warm light kindling in the cold and the quiet, joining a galaxy that has been lighting itself, star by star, for billions of years. Most stars in the galaxy are small, cool, and long-lived. When we picture a star, we often imagine something like our Sun, but the Sun is larger and brighter than most. The great majority of stars in the Milky Way, perhaps 3 out of every 4, are red dwarfs, dim, cool, and small, glowing faintly with a soft red light. Not a single one is bright enough to see with the naked eye, and yet the nearest star to our own Sun, Proxima Centauri, is exactly this kind of quiet ember. They are so frugal with their fuel that they can burn steadily for trillions of years, far longer than the universe has yet existed. The galaxy is filled, quietly, with these patient little lights, countless of them, too faint to see, each one destined to outlast every brilliant star we know. Many stars are born in pairs and never drift apart. Our Sun travels alone, but that is not the most common way. A great many stars are born in pairs, 2 suns bound together, circling a shared center for billions of years. In fact, our very nearest neighbors, the Alpha Centauri stars, are a family of 3, bound in a slow gravitational dance. Some pairs orbit so closely they nearly touch. Others are separated by vast, slow distances. On a world orbiting such a pair, you might see 2 suns rise together, or 2 shadows stretch across the ground. Across the galaxy, countless stars move through the dark with a lifelong companion at their side, turning together, quietly, for the whole length of their lives. The atoms in your body were forged inside stars. The carbon in your cells, the oxygen you are breathing, the iron in your blood, none of it existed when the universe began. It was all created inside stars, forged in their hot cores over billions of years, and scattered into space when those stars died. Even the heaviest elements, like the gold in a ring, were likely made in the violent collision of 2 dead stars. That matter drifted through space, gathered into new clouds, and became new stars, new worlds, and eventually, you. You are not separate from the Milky Way. You are made of it, old starlight, given a body for a little while, resting quietly beneath the same sky that made you. When a great star dies, it briefly outshines a billion suns. The most massive stars end their lives in a single, staggering explosion, a supernova. In its final moment, the star collapses and detonates, blazing so brightly that for a few weeks it can outshine every other star in its galaxy combined. The last one seen with the naked eye in our own Milky Way blazed in the year 1604, bright enough to be watched in daylight. And in that violent death, a star forges and scatters heavy elements, flinging them out to enrich the clouds where new stars will form, and leaving behind a dense, dark remnant. Destruction and creation are the same act here. From the death of one star comes the raw material for 1,000 new worlds. A spoonful of a dead star can weigh 1 billion tons. When a massive star collapses, its core can be crushed into a neutron star, an object with up to twice the mass of the Sun, packed into a sphere barely 20 kilometers wide, the size of a city. The matter inside is so unimaginably dense that a single teaspoon of it would weigh about 1 billion tons here on Earth. So much is squeezed into so little that its surface gravity is billions of times stronger than ours. These are among the strangest objects in the galaxy, tiny, silent, impossibly heavy remnants, spinning in the deep. What remains of a star that once lit up the heavens can be smaller than a mountain and heavier than the sea. Some dead stars sweep the galaxy like lighthouses. Certain neutron stars spin at tremendous speed, beaming radio waves out into space. As they turn, the beam sweeps past us again and again, arriving as a faint, perfectly regular pulse. We call them pulsars, and some spin hundreds of times each second, yet keep time so precisely they rival the finest clocks ever built. When the first was found in 1967, its signal was so regular that astronomers half-jokingly labeled it "little green men," wondering for a moment if it was a message. Today, these tireless beacons scattered across the galaxy help us test the laws of gravity and even sense ripples in space itself. Long after their light as stars has faded, they keep turning, keeping time, steady, patient heartbeats echoing quietly through the Milky Way. Some of these stellar remnants are stranger still, wrapped in forces almost beyond imagining. The most magnetic objects in the universe are dead stars. A rare kind of neutron star, called a magnetar, carries a magnetic field so powerful it defies comprehension, trillions of times stronger than the Earth's, the strongest magnets known to exist. In 2004, a sudden flare from one such magnetar, 50,000 light-years away, briefly disturbed the upper edge of Earth's atmosphere. If one drifted as close as the Moon, its field would scramble the data on every device on the planet. Get close enough, and it would pull apart the very atoms of your body. And yet they are small, quiet things, spinning alone in the void. The galaxy hides such extremes within it, objects of unimaginable violence, resting silently far away, harming no one, turning slowly in the deep. Our sun is an ordinary star, about halfway through its life. For all that it means to us, the sun is a fairly average star, a middle-sized, middle-aged yellow dwarf, one of a few 100 billion. And yet, because most stars are dim red dwarfs, our sun is actually brighter than perhaps 95% of the stars in the galaxy. It has been shining for about 4.5 billion years, and it has roughly that long again before its fuel begins to run low. So the sun that warmed your day today is only halfway through its long, steady life. It is neither the brightest nor the largest, but it is faithful and calm and ours, a quiet, dependable star in a quiet corner of the galaxy. Some stars are so large they could swallow our entire solar system. Among the stars of the Milky Way are true giants, swollen red supergiants, hundreds of times wider than the sun. If one were placed where our sun sits, its glowing surface would engulf Mercury, Venus, Earth, and Mars, reaching out past the asteroid belt. The very largest known stars are so vast that light itself would take hours to travel from one side to the other. Betelgeuse, in the shoulder of Orion, is one such supergiant, nearing the end of its life and destined one day to explode. These giants are brief and unstable, living fast and dying young, vast, restless suns, glowing red against the black, already close to their spectacular end. Our sun will one day become a slowly cooling ember. When the sun finally exhausts its fuel, it will not explode. Instead, it will swell into a red giant, then gently shed its outer layers, leaving behind only its hot, exposed core, a white dwarf, about the size of the Earth, yet holding much of the sun's mass. There it will sit, no longer burning, simply glowing from leftover heat, cooling so slowly that it will take far longer than the present age of the universe to fade to black. The sun's final form is a quiet one, a small, dimming ember, drifting through the deep, releasing the last of its warmth into the dark with unhurried, endless patience. Ancient swarms of stars orbit high above the galaxy. Circling the Milky Way, far out in its halo, are about 150 globular clusters, dense, spherical swarms of hundreds of thousands of stars, bound tightly together by gravity. The largest, Omega Centauri, holds some 10 million stars in a single glittering ball. Many are extraordinarily old, nearly as ancient as the universe itself, and they have been orbiting our galaxy since long before the sun was born. Inside them, the stars are packed so closely that a night sky there would blaze with countless suns and never grow fully dark. They are among the oldest structures in the galaxy, quiet, glittering relics, drifting far above the disk, keeping their ancient light. The stars our sun was born with are lost among the billions. Our sun did not form alone. It was born within a cluster of perhaps a few thousand sibling stars, all condensing from the same great cloud. But over billions of years, as they orbited the galaxy at slightly different speeds, that family slowly drifted apart. Its brothers and sisters are out there still, scattered now across the whole Milky Way, unrecognizable among the countless other stars, though astronomers, by matching their chemistry, have begun to identify a few likely candidates. Somewhere in the night sky tonight shines a star born beside our own, a lost sibling of the sun, wandering the galaxy, its kinship long forgotten, its light still quietly reaching us. Every star, every cloud, every dying ember shines against something we cannot see. For most of the galaxy is not starlight at all. It is darkness and unseen forces. Let us drift now into the invisible galaxy. Most of the galaxy is made of something we cannot see. Everything you can observe in the Milky Way, every star, every glowing cloud, every planet, makes up only a small fraction of what is truly here. The vast majority of our galaxy's mass is invisible. We call it dark matter, and it outweighs all the ordinary matter, every star and planet and drifting cloud, by roughly 5 to 1. It gives off no light, no heat, no signal of any kind. We know it exists only because we feel its gravity, holding the galaxy together. You are lying tonight inside something mostly unseen, a great, silent presence woven through all the space around you, felt but never glimpsed. An enormous invisible halo surrounds the entire galaxy. The bright, star-filled disk of the Milky Way is only the visible center of something far larger. Wrapped around it all is a vast, roughly spherical halo of dark matter, reaching out perhaps hundreds of thousands of light years, many times beyond the edge of the stars. It is this halo that gives our galaxy most of its enormous mass, more than 1 trillion times the mass of the Sun. This unseen halo is the true bulk of our home, the deep foundation on which the glowing spiral floats like a thin film of light. When you picture the Milky Way, you are picturing only its shining surface. The greater part is dark, quiet, and immense, cradling the stars from far beyond where any of them shine. We still have no idea what dark matter actually is. For all that it shapes our galaxy, dark matter remains one of the deepest mysteries in science. It is not made of ordinary atoms. It does not touch light. It passes straight through solid matter, through the earth, through you, as though nothing were there. It may be some entirely new kind of particle, one we have never managed to catch, and scientists have built delicate detectors deep underground, shielded from all interference, waiting patiently for a single whisper of it. Still it hides. Something enormous and unknown fills our galaxy and shapes its every motion, and after decades of searching, we can only say, honestly and humbly, that we do not yet know what it is. Stars at the galaxy's edge move too fast, and that is how we found the darkness. By all the rules we know, stars far out at the rim of the galaxy should orbit slowly, loosely held by the gravity of the visible stars within. Yet they race around just as fast as the inner stars, as though gripped by far more mass than we can see. The astronomer Vera Rubin measured this carefully in the 1970s, and her quiet, meticulous work made the case for dark matter impossible to ignore. That single, puzzling fact, stars moving too quickly to explain, was one of the first clues that something invisible was there. The galaxy spins as if held by an unseen hand. We felt the darkness long before we understood it, in the strange, swift turning of the outer stars. The space between the stars is not empty. It may look as though the galaxy is made of stars, scattered through a perfect void, but between them drifts a thin, cold mist of gas and dust, the interstellar medium. It is faint almost beyond measure, on average just a single atom in every cubic centimeter, thinner than the finest vacuum we can make in a laboratory. Yet spread across such vast distances, it adds up to the raw material for millions of future stars. From this quiet fog, new suns are slowly born, and into it, dying stars return their dust. The emptiness between the stars is not empty at all, but a gentle, drifting sea from which the galaxy renews itself. Tiny grains of cosmic dust are the seeds of worlds. Floating through the galaxy are countless grains of dust, each far smaller than a speck of sand, soot and ice and mineral, cast off by dying stars. They seem insignificant, and yet they are essential. Around young stars, these grains gather and stick together, growing slowly over ages into pebbles, then boulders, then whole planets. Woven among them, astronomers have even found complex carbon molecules, close cousins of the chemistry that would one day give rise to life. The earth beneath you, and every world in the sky, began as this faint stardust adrift in the void. From the smallest specks, the galaxy builds its largest things, patiently, over unimaginable spans of time. An invisible magnetic field threads through the whole galaxy. Though we cannot see or feel it, the Milky Way is laced with a vast, gentle magnetic field, stretching along the spiral arms and rising into the halo. It is astonishingly weak, only a few millionths of the strength of Earth's own field, yet spread across such enormous distances that it shapes how gas clouds collapse, how cosmic particles travel, and how new stars are born. Astronomers trace it by the faint twist it gives to starlight passing through. It runs through the galaxy like a quiet current, invisible and everywhere. Our home does not only shine with light, it hums softly with magnetism, a subtle field woven all through the dark. Particles from exploded stars are passing through you right now. At this very moment, tiny particles launched by ancient stellar explosions are streaming through your body, through your walls, through the Earth itself. We call them cosmic rays, and they travel across the galaxy at nearly the speed of light, guided by its magnetic field. They were discovered in 1912, when a physicist named Victor Hess rode a balloon high into the sky and found the mysterious radiation growing stronger, not weaker, proof it was raining down from space. Most pass through you without a trace, silent and unfelt, carrying with them the story of some distant, long-dead star. Even here, in the quiet of your room, the galaxy is gently passing through you, an unnoticed rain of ancient particles, whispering of far-off fires as you rest. Some of the most beautiful clouds in the galaxy glow with their own light. Where hot young stars are born, their intense radiation can set the surrounding gas aglow, lighting up vast clouds in soft, shining color. These are the emission nebulae, the glowing crimson and rose-colored clouds seen in the great telescope images, some spanning dozens of light years. Their deep red comes from hydrogen itself, glowing as it is energized by the young stars within, like embers catching light. They are among the most beautiful sights in the Milky Way, enormous, luminous veils of gas, shaped by starlight and stellar wind. And within them, quietly, new stars continue to form, cradles of light, glowing gently in the hush, giving birth to the next generation of suns. Not all the clouds of the galaxy shine. Some are dark and hide the light behind them. Some clouds in the galaxy are so dark they blot out the stars. Alongside the glowing nebulae drift other clouds, cold, dense, and utterly dark. They give off no light of their own and are so thick that they hide the stars behind them, appearing as inky gaps and rifts across the bright band of the Milky Way. The old stargazers of some cultures saw shapes in these dark lanes and told stories of them. The first peoples of Australia, for one, saw in the dark rifts a great celestial emu stretched across the sky. Within their cold interiors, shielded from the light, the galaxy's next stars are quietly forming, new suns gathering in the darkest, most hidden places of all. The galaxy endlessly recycles itself. Nothing in the Milky Way is truly wasted. Stars form from clouds of gas, live their long lives, and at their death return that gas, now enriched with new elements, back into space. From those enriched clouds, new stars are born, a little richer than the last, carrying more oxygen, more carbon, more iron than the generation before. Round and round it goes, over billions of years, each generation of stars built from the remains of the ones that came before. The galaxy is a vast, slow act of recycling, endlessly turning death back into birth, and you, made of once dead stars, are part of that same unbroken cycle. The clouds where stars are born are colder than almost anything. The great molecular clouds that give birth to stars are among the coldest places in the entire galaxy, hovering only about 10 degrees above absolute zero, the lowest temperature anything can reach. They are colder than the frozen edge of the solar system, colder than almost anything in nature. It is this deep cold that lets gravity slowly draw the gas together, without the warmth to push it apart. So the fiercest, hottest things in the universe, the stars, are born from the coldest, quietest clouds of all. From near-perfect stillness and cold comes light. The galaxy shines in colors our eyes will never see. To our eyes, the Milky Way is a band of soft white light, but that is only the smallest part of what it truly emits. The galaxy glows in radio waves, in infrared warmth, in X-rays and gamma rays, whole hidden skies of light, invisible to us, revealing warm dust, exploded stars, and the fierce heart at its center. Each time we learn to see in a new kind of light, an unknown galaxy revealed itself. Only with special telescopes can we glimpse them at all. Our galaxy is far richer and stranger than any single pair of eyes can know. A symphony of light playing on in colors we were simply never built to see. The galaxy is wrapped in a vast halo of hot gas. Beyond the visible disk, surrounding the whole Milky Way, lies an enormous, tenuous halo of gas, heated to over 1,000,000 degrees, so thin and so faint that we only recently confirmed it is there. This great hot shroud may hold as much ordinary matter as all the galaxy's stars combined, and may account for some of the everyday matter astronomers had long struggled to find. It cradles the spiral quietly within it. Our home is not a lonely island of light in empty space. It is enfolded in an unseen atmosphere of its own, a warm and silent halo holding the stars gently within its vast embrace. We have wandered the heart of the galaxy, its stars, and its invisible depths. Let us come home now, to our own quiet corner of the Milky Way and the neighborhood where the sun drifts. Our sun lives in a quiet, minor branch of the galaxy. We do not live in one of the great spiral arms of the Milky Way. Our sun drifts within a smaller, fainter spur of stars, tucked between two of the larger arms, a feature astronomers call the Orion Arm, or simply the local arm. Modest as it is, it holds many of the bright stars and glowing nebulae we know best, including the great nursery in Orion. It is an uncrowded lane in the galaxy, away from the busiest regions of star birth and death. There is a gentleness to our address. We inhabit a calm and unremarkable side street of the Milky Way, far from the crowds and the fireworks, in a peaceful stretch of the spiral that has let our world grow old undisturbed. We live about halfway between the center and the edge. The sun orbits the galactic heart from a distance of roughly 26,000 light-years, a little over halfway out toward the rim. It is, in many ways, a fortunate place to be, far enough from the crowded, radiation-soaked core that the deadly blast of a nearby exploding star is rare, yet not so distant as to be starved of the raw material for planets and life. Our home sits in a quiet middle ground, neither at the dangerous center nor the empty edge. Out here, in this balanced and gentle region, the Earth has orbited safely for billions of untroubled years. Our solar system floats inside a bubble blown by dying stars. The sun is currently drifting through a strange region of space, a vast, nearly empty cavity in the interstellar gas called the local bubble, some 300 light-years across. It was carved out over millions of years by a series of dying stars, perhaps 15 of them, whose supernovae swept the gas outward and left a hollow behind. Curiously, the gas piled up on the bubble's inner walls is now itself giving birth to new stars. We are passing through that hollow now, our whole solar system floating within this quiet, cleared-out pocket in the galaxy, a calm bubble in the mist, blown open by ancient stars that died before our species ever was. Even our nearest neighbor's star is unimaginably far away. The closest star system to our own is Alpha Centauri, and it lies more than 4 light-years away. Its faintest member, the red dwarf Proxima Centauri, is the true nearest star, and it even holds a small planet circling in its gentle warmth. Yet the distance is so vast, it is hard to hold in the mind. Even traveling at the speed of light, you would journey for over 4 years to reach it. And with today's fastest spacecraft, it would take tens of thousands of years. And that is our nearest neighbor. The stars, for all their beauty, are profoundly far apart, each one a distant island of light, separated from the next by oceans of silent, empty space. As it orbits, the sun gently bobs up and down. The sun's long journey around the galaxy is not a flat circle. As it travels, It also drifts slowly up and down through the plane of the galactic disk, rising above it and sinking below it, over and over, like a horse on a carousel that gently rises and falls. It crosses the crowded midplane roughly every 30 million years, and some scientists have even wondered whether these passages nudge distant comets loose far out at the solar system's edge. Right now, we are drifting slightly above that midplane. Our path through the Milky Way is not a simple loop, but a soft, wave-like weaving, a slow rise and fall through the sea of stars. Our whole solar system is sailing toward a distant star. Relative to the stars around us, the sun is not standing still. It is drifting through the stars toward a point in the sky in the direction of the constellation Hercules, near the bright star Vega, carrying all its planets with it at about 19 kilometers every second. Astronomers call this direction the solar apex, the way we are headed through the local sea of stars. So even as the Earth circles the sun itself is voyaging onward, and all of us together are quietly sailing toward a far-off region of the galaxy we will never reach. Right now, we are drifting through a wisp of interstellar cloud. For the last several thousand years, our solar system has been passing through a faint, warm wisp of gas known as the local interstellar cloud, a thin tendril of the interstellar medium about 30 light-years across, drifting through the local bubble. The sun entered it only some tens of thousands of years ago, and it is impossibly tenuous, far emptier than any vacuum we can make. Yet the sun is sailing through it even now. In time, we will drift out the other side and into whatever lies beyond. Our journey among the stars carries us endlessly into new surroundings, so slowly that a single passage can outlast all of recorded human history. The sun blows a vast protective bubble around us. The sun sends out a constant stream of particles in every direction, the solar wind, and this wind inflates an enormous bubble around the whole solar system, called the heliosphere. It reaches far beyond the most distant planets, holding back much of the harsh radiation of interstellar space and gently shielding the worlds within. Only 2 spacecraft, the Voyager probes launched in the 1970s, have ever crossed its distant edge, Voyager 1 slipping into true interstellar space in 2012, some 18 billion kilometers from home. We live deep inside this quiet, protective bubble, cradled by our own star's breath, sheltered within a haven the sun itself creates. Our place in the galaxy is not only about where we are, but about how kind that place has been to us. We may live in a rare, life-friendly zone of the galaxy. Some scientists believe there may be a galactic habitable zone, a favored region of the Milky Way, neither too close to the violent center nor too far into the barren outskirts, where the conditions for life can quietly endure. Too near the core, deadly radiation and exploding stars would trouble any world. Too far out, there are too few heavy elements to build rocky planets at all. If such a zone exists, our solar system sits comfortably within it. It is a humbling thought that our long, unbroken stretch of calm may owe as much to where we are in the galaxy as to anything else. We may be resting, tonight, in one of the gentlest neighborhoods the whole Milky Way has to offer. The constellations are slowly coming apart. The patterns we see in the night sky feel timeless, but they are not. Every star is drifting on its own path through the galaxy, and over tens of thousands of years, these slow motions gradually reshape the constellations. In 50,000 years, the familiar Big Dipper will have bent out of its shape entirely, its stars carried in different directions. The forms our ancestors named will, in time, stretch and blur and dissolve into arrangements no one has ever seen. The sky is not a fixed painting, but a slow and living thing. The stars you fall asleep beneath tonight are quietly drifting, and one distant day, they will trace patterns entirely their own. Now and then, a visitor from another star drifts through. In recent years, astronomers have spotted objects passing through our solar system that did not come from here at all. Wanderers flung out from other star systems, crossing the vast dark between the stars, briefly sailing through our own neighborhood before continuing on. The first, discovered in 2017, was a strange, elongated shard we named Oumuamua. A second, an icy comet from another star, followed just 2 years later. These interstellar travelers are messengers from distant, unknown worlds, silently passing through and moving on. The galaxy, it turns out, is quietly exchanging pieces of itself, drifting fragments from one star to another across the deep. Countless worlds wander the galaxy with no star at all. Not every planet orbits a sun. Drifting through the Milky Way are vast numbers of rogue planets, worlds cast out of their solar systems long ago, or born alone in the cold, now wandering the galaxy without a star to warm them. Astronomers glimpse them only rarely, by the faint way their gravity bends the light of a star behind them, and some now suspect these starless worlds may outnumber all the stars in the galaxy. It is a lonely and haunting thought, whole planets, some perhaps as large as Jupiter, drifting silently through the cold and the dark, unlit and unseen, journeying on through the emptiness forever. Over time, other stars drift close to our sun, then pass on. The stars are not fixed neighbors. As they and the sun travel their separate orbits, they slowly approach one another and drift apart again over vast stretches of time. About 70,000 years ago, a small red star, known as Schultz's star, drifted through the distant outer reaches of our solar system, perhaps brushing the cloud of comets that surrounds it. And in a little over 1 million years, another, Gliese 710, will pass closer still. None will collide. The distances are far too great, but the galaxy's stars are slowly rearranging around us, quiet ships passing in a slow and silent sea. The light from the night sky is a message from the past. When you look up at the stars, you are not seeing them as they are, but as they were. Even the sun you see is 8 minutes old. The light of more distant stars has traveled for years, for centuries, for thousands of years to reach your eyes, so you see each one as it looked when that light began its journey. Some may have changed since then. A few may no longer shine at all. The night sky is a gathering of old light, a portrait of the galaxy's past, painted across the dark. To gaze upward is to look, quietly, back through time. Our neighborhood is vast beyond imagining, and yet it is only one small part of a still greater whole. Let us drift outward now, past the edge of the galaxy, to the family of galaxies our own belongs to. The Milky Way has smaller galaxies orbiting it. Our galaxy does not travel alone. Circling it are a number of smaller companion galaxies held by its gravity. The two most famous, the Magellanic Clouds, are visible to the naked eye from the southern half of the world, two soft, glowing patches drifting near the Milky Way's band, like faint reflections of our galaxy in the night. The larger lies about 160,000 light-years away, holding billions of stars of its own. For countless generations, southern sky watchers have known them. They are among our nearest galactic neighbors, quietly keeping pace with our home, two luminous companions accompanying the Milky Way on its long journey through space. Our galaxy is slowly pulling a river of gas from its companions. As the Magellanic Clouds orbit the Milky Way, our galaxy's gravity is gently stripping gas away from them, drawing it out into an immense stream that trails more than halfway across the sky. The Magellanic Stream, revealed by radio telescopes tuned to the glow of cold hydrogen. It is a slow and silent theft, feeding our galaxy with fresh material for making new stars. This is how galaxies grow, not only by dramatic collisions, but by the quiet, patient gathering of gas from their smaller neighbors. Even now, our home is gently drawing sustenance from the companions that drift beside it. Dozens of tiny galaxies swarm around the Milky Way. Beyond the bright Magellanic Clouds, our galaxy is surrounded by dozens of far fainter dwarf galaxies, small, dim collections of stars, some holding only a few thousand suns, and so sparse they were discovered only in the last few years. Strangely, many are bound together almost entirely by dark matter, with barely enough starlight to be seen at all. They orbit the Milky Way like a loose swarm of quiet satellites, and one by one, over billions of years, many will be drawn in and absorbed. All around our galaxy, unseen, drift these faint companions, humble worlds, circling patiently, awaiting their slow embrace with our own. Our galaxy belongs to a small family of galaxies. The Milky Way is part of a gravitationally bound gathering called the Local Group, a collection of roughly 80 galaxies spread across some 10 million light-years, drifting through space together. Most are small dwarf galaxies, but three spirals stand out: our own Milky Way, the mighty Andromeda, and the smaller Triangulum. Bound together by gravity, they journey through the wider universe as one. We are not a solitary island of stars, but part of a small, close-knit neighborhood of galaxies, a quiet family, traveling together through the immense dark. The farthest thing you can see with your own eyes is another galaxy. On a clear, dark night, in the constellation Andromeda, you can find a faint, hazy smudge of light. That smudge is the Andromeda Galaxy, known to astronomers as M31, an entire spiral of perhaps 1 trillion stars, wider than our own Milky Way, some 2.5 million light-years away. It is the most distant thing the human eye can see unaided. When you glimpse it, the light entering your eyes left Andromeda 2.5 million years ago, before our species even existed. To see it is to look across an almost unimaginable gulf of space and time, with nothing but your own two eyes. Andromeda and the Milky Way are drifting toward each other's arms. Though separated by millions of light-years, Andromeda and our Milky Way are slowly falling together, drawn by their mutual gravity, closing the distance at over 100 kilometers each second. In some 4 billion years, though the very newest measurements leave a little room for doubt, they may meet, sweep through one another, and over hundreds of millions of years merge into a single, greater galaxy. Our descendants, if any remain, would see Andromeda swell across the night sky before the two galaxies become one. Two great spirals are quietly reaching for each other across the dark, and one distant day they may join. Our entire galaxy is being pulled toward something immense. The Milky Way, and the whole local group with it, is drifting through space toward a vast and distant concentration of mass, a gravitational pull so great that astronomers named it the Great Attractor. It lies some 200 million light-years away, hidden behind the band of our own galaxy in a region we cannot easily see through, so that its full nature remains a mystery. Yet it draws us and thousands of other galaxies gently toward it. We are being carried, along with everything we know, toward a destination we cannot clearly see, the whole galaxy falling, slowly and silently, in a direction shaped by unseen giants far across the universe. We are moving through the universe at breathtaking speed and never feel it. When measured against the faint afterglow of the Big Bang, which fills all of space, our galaxy is racing along at roughly 600 kilometers every second. Astronomers read this motion in the way that ancient light appears very slightly warmer ahead of us and cooler behind. In the time it takes to read this sentence, we have traveled thousands of kilometers through the cosmos. And yet there is no wind, no rush, no sense of motion at all. We drift through the universe at astonishing speed, in perfect, silent calm. You are lying still and hurtling through space, both at once, carried smoothly through the dark, feeling nothing but rest. Our galaxy's motion is part of a pattern far larger than the local group, a structure so vast it is difficult to imagine. Our galaxy is a single thread in an immense cosmic structure. Zoom far enough out, and the Milky Way becomes a tiny part of something staggering. In 2014, astronomers mapped how galaxies flow through our region of space and found we belong to a vast supercluster, some 500 million light-years across, and home to 100,000 galaxies, which they named Laniakea, a Hawaiian word meaning immense heaven. Within it, all those galaxies drift along great converging currents, gently gravitating together. Our whole galaxy is but one bright speck on the outskirts of this enormous river of stars. The scales simply keep growing, each vaster than the last, until the mind can only rest, quietly, in the sheer immensity of it all. Beyond our galactic family, everything is rushing away. While the galaxies of our local group are bound together and will remain so, everything beyond it is steadily receding. Space itself is expanding, carrying the distant galaxies away from us, and the farther they are, the faster they retreat, until, beyond a certain distance, they slip away faster than their light can ever reach us again. Across billions of years, the universe is slowly spreading thinner and wider. Our little family of galaxies drifts on together, an island of nearness in an ever-expanding sea. Far away, in every direction, the other galaxies are quietly slipping toward the horizon, drawn apart by the gentle, ceaseless stretching of space. The Milky Way is one of perhaps 2 trillion galaxies. As grand as our galaxy is, it is far from alone. Careful surveys of the deep sky suggest the observable universe holds something like 2 trillion galaxies, each one a vast island of stars, many with their own hundreds of billions of suns, and most far too faint and distant for any eye to see. Our Milky Way, home to everything we have ever known, is a single ordinary galaxy among a number too large to truly comprehend. And yet it is ours. In all that unimaginable multitude, this one quiet spiral is the one that made us, the one we rest within tonight, our small, particular home in a universe of countless others. Our galactic family will stay together, even as the universe drifts apart. There is a quiet comfort hidden in the expanding universe. Though the distant galaxies are receding, our own local group is held firmly together by gravity, its bonds far stronger than the gentle stretching of space, and so it will not be pulled apart. Over the eons, Andromeda and the Milky Way and their companions will merge and settle into a single great galaxy, drifting on together long after the rest of the cosmos has faded beyond view. In an expanding, thinning universe, our galactic family remains bound, a lasting togetherness in the dark, a home that endures while all else drifts away. Galaxies are strung across the universe like a great cosmic web. On the very largest scale, the galaxies of the universe are not scattered at random. They gather along immense threads and sheets, with vast, dark, empty voids between them, some voids stretching hundreds of millions of light-years across, nearly empty of everything. This grand structure, astronomers call the cosmic web, and it traces the hidden scaffolding of dark matter beneath. Our Milky Way sits along one of these luminous filaments, a single bright bead on a strand of galaxies stretching across the cosmos. Even at the grandest scale imaginable, there is pattern, and there is beauty, a delicate, glowing web, woven through the darkness, holding our home among its countless shining strands. One day, the Milky Way and Andromeda will share a single name. When our galaxy and Andromeda finally complete their long merger, billions of years from now, the 2 spirals will no longer exist as separate things. Their graceful arms will be scrambled and swept away, and their stars will settle together into one vast new galaxy, a great, rounded cloud of suns that astronomers have already playfully named Milky Way. Our own sun may be flung far out into its quiet outskirts, carried along for the ride. The Milky Way as we know it, the shape that has held the sun for so long, will gently come to an end, transformed into something new and greater. Even galaxies are not forever. They too are born, they change, and they slowly become something else. We have drifted outward as far as the eye of the mind can reach. Now let us turn, gently, toward time itself, toward the deep future of our galaxy, and the quiet place we hold within its long, unfolding story. One distant day, the galaxy will stop making new stars. The Milky Way has been forming stars for billions of years, but it cannot do so forever. Slowly, over immense spans of time, its stores of cold gas will be used up, and fewer new stars will be born. Astronomers believe the last new stars may kindle perhaps 100 trillion years from now, a stretch of time so long the whole present age of the universe is only the faintest sliver of it. Far in that future, the final stellar nursery will grow quiet, and no new suns will ever be born again. The galaxy will still shine on with the stars it already holds, but its long age of creation will gently draw to a close. Even the making of stars is not endless. It, too, has its season. Our sun has about 5 billion more years to shine. The sun will not last forever, but its remaining life is vast beyond human measure. Some 5 billion years still to come, half of a total life near 10 billion years. For all that time, it will go on shining, much as it does now, warming the earth, rising and setting over whatever the world becomes. There is no need to fear its ending. It lies unthinkably far away, beyond every future we could ever know. The star that warmed your day today will keep its faithful watch for billions of years more, steady, patient, and in no hurry at all to fade. In its final age, the sun will swell into a giant. When the sun at last begins to exhaust its fuel, it will slowly expand into an enormous red giant, growing until it fills much of the inner sky and swallows the closest planets. Then, gently, it will cast off its outer layers into a glowing shell of gas, a planetary nebula, one of the loveliest sights in the galaxy, before settling down to fade. The Earth's distant fate rests in that far-off swelling, but this lies billions of years away, past the end of every story we can tell. It is not a thing to trouble the night. It is only the natural, unhurried close of a star's long life, written far beyond the horizon of time. The galaxy will keep turning long after the sun is gone. When the sun has finished its life and cooled into a quiet ember, the Milky Way will scarcely notice. It will go on turning, forming what stars it can, drifting through space, as it has for billions of years, and will for hundreds of billions more. Our sun is one light among hundreds of billions, precious beyond measure to us, yet a single small candle in an immense and enduring galaxy. There is a strange peace in that thought. The great wheel of the Milky Way turns on, patient and vast, carrying the memory of every star it has ever held gently into the future. In the far future, the night sky will grow quieter. As the universe expands, the distant galaxies are slowly drifting beyond our reach. Far in the future, they will have receded so far that they can no longer be seen at all, leaving only our own merged galaxy alone in the visible dark. Astronomers living then would have no way to know that other galaxies ever existed, or that the universe was born and is expanding, the evidence simply gone from the sky. We are fortunate to live now, while the sky is still full, and the great story is still written overhead, while so many galaxies still shine within our view, waiting to be wondered at. The last stars will be small, red, and astonishingly patient. When the great bright stars have all burned out, the galaxy will still glow, faintly, for an almost unimaginable length of time. The smallest red dwarf stars burn their fuel so slowly that some may shine for 10 trillion years, nearly 1,000 times the present age of the universe. Long after the sun and all its kind are gone, These tiny embers will still be glowing softly through the long night, the last faithful lights of the Milky Way. The galaxy's final age will be a long, dim, peaceful twilight, lit by the most patient stars of all. The galaxy has no true edge, it simply fades away. If you journeyed outward from the center of the Milky Way, you would never cross a clear boundary, never find a wall or an edge. The stars would only grow sparser and sparser, the light dimmer, and even the faint halo of oldest stars trails off for hundreds of thousands of light years, thinning until at last you could not say whether you were still within the galaxy or beyond it. Our home does not end so much as gently dissolve into the dark. Like so many things in nature, the Milky Way has no sharp border, only a soft, quiet fading, a slow surrender of stars into the surrounding night. Our galaxy is almost entirely empty space. For all its hundreds of billions of stars, the Milky Way is overwhelmingly empty. The stars are so tiny compared to the distances between them that if you flew through the galaxy at random, you could travel for an eternity and almost never come near one. In all its long history, our own sun has likely never once passed close to another star. The galaxy is less a crowd than a vast, dark stillness, with a few scattered lights drifting far apart. There is a deep calm in that emptiness, a quiet, spacious dark in which each star is a rare and gentle warmth, and the silence between them is the greater part of home. And within all that emptiness, all that motion, there is a stillness worth resting in. Shrink the galaxy down, and the stars become grains of sand miles apart. The scale of the Milky Way is almost impossible to feel, so imagine shrinking it. If the sun were a single grain of sand, its nearest neighbor star would be another grain of sand many kilometers away. And even shrunk to that grain of sand scale, the whole galaxy would still stretch wider than an entire continent, its 100 billion grains adrift in the black. The stars are unimaginably small and unimaginably far apart. To picture it is to feel the deep and gentle spaciousness of the galaxy, a handful of quiet lights, scattered across distances too vast and too peaceful to ever truly cross. All of this vast motion happens in perfect silence. The galaxy is filled with movement, stars racing, gas swirling, whole spiral arms turning through the void. And yet all of it unfolds in complete silence. Sound needs air to travel, and the space between the stars is far too empty to carry it. So no matter how violent the event, from the birth of a star to a supernova blazing brighter than a billion suns, not a whisper of it ever reaches the ear. The entire drama of the Milky Way plays out in absolute quiet. It is the most silent thing there is, a vast, turning galaxy, moving through the dark without a single sound. Our whole story is only a brief moment in the galaxy's long life. The Milky Way has been turning for more than 13 billion years. If you imagine that entire life as a single year, all of recorded human history, every civilization, every life ever lived, would flash by in the final few seconds before midnight. We arrived only a moment ago in the galaxy's reckoning, and our time here is impossibly brief, and yet there is no sadness in it, only a kind of wonder that in all these billions of years, we are here now, awake for this small moment, able to look up and understand even a little of the vast ancient home that made us. In us, the galaxy has come to know itself. Here is perhaps the strangest fact of all. The atoms that make you were forged inside the stars of the Milky Way and gathered over billions of years into a being that can look back at the galaxy and wonder. As the astronomer Carl Sagan once said, "We are a way for the cosmos to know itself." In a very real sense, you are the galaxy grown aware, stardust that can gaze at the stars, matter that has learned to marvel at where it came from. When you contemplate the Milky Way tonight, the galaxy is, through you, quietly contemplating itself. One day, your atoms will return to the galaxy and shine again. Nothing in the Milky Way is ever truly lost. It is only borrowed and given back. The atoms that make you now were once part of ancient stars, and one distant day they will return to the galaxy again, to drift in its clouds and perhaps, in the fullness of time, to help kindle new stars and new worlds, new oceans and new life. You are a brief gathering of stardust, on loan from the galaxy for a little while, and when the loan is repaid, that same matter will go on, shining somewhere, long after, part of the Milky Way forever. For all its immensity, the galaxy is your home. It is easy to feel small beneath such vastness, but the Milky Way is not a cold or foreign place. It is where you were made, where you live, where every person you have ever loved has lived and breathed. Every sunrise you have ever seen, every face, every song, every quiet evening like this one has happened here, within this single spiral of stars. Its stars forged the iron in your blood. Its quiet corner cradled the world that gave you life. However enormous it is, the galaxy is not somewhere far away. It is home, and you belong to it completely. You are not lost within the Milky Way. You are held by it, resting safely in its arm, exactly where you are meant to be. And tonight, the whole galaxy is being quietly witnessed by you. Out of 13 billion years, out of 100 billion stars, out of all the vast and silent dark, there is this, a single, resting mind, here and now, aware of it all. For all its black holes and colliding galaxies, its ancient stars and invisible matter, the most remarkable thing the Milky Way has ever made may simply be a quiet moment of wonder on a small, blue world at the end of an ordinary day. The galaxy has turned for ages to arrive at this instant, when you might lie still and take it gently in. You are the Milky Way's witness tonight, its warmth, its wonder, its awareness, gathered for a little while into one peaceful soul, drifting towards sleep beneath the stars that made you. And so our journey through the galaxy comes gently to its close. To think of all of this as you drift towards sleep, the turning arms, the ancient stars, the quiet monster at the heart, the vast unseen dark, is not to feel small and separate. It is to feel connected, woven into something old and beautiful and enduring. For you are small, but you are not alone. You are fleeting, yet part of something that has lasted billions of years. The same galaxy that made the stars made you, and the same quiet dark that cradles 100 billion suns is cradling you now, softly, tonight. So let your breathing grow long and slow. Let your body sink a little deeper into rest, and imagine, High above you, that faint band of light, our galaxy, the Milky Way, turning slowly and silently through the dark, holding you gently within one of its quiet spiral arms. The glow of a single star, the glow of 100 billion suns, the glow of the whole Milky Way, drifting on without a sound, carrying you and everyone you love quietly through the night. Thank you for spending this quiet time here beneath the stars. Whenever sleep feels far away, you are always welcome to return, and we will wander the galaxy together again. If you happen to still be awake, the next journey is waiting whenever you wish it. But for now, there is nothing left to do but rest. May your night be peaceful. May your thoughts grow light. And may sleep come easily and carry you gently, like starlight drifting across the dark into soft and quiet dreams. Good night, and sleep well.
you.